Hey, what's up guys? Today let's look at the Lintcode problem number 597, subtree with maximum average. So in this problem, you were given a binary tree. You need to find the subtree with the maximum average, and we need to return the root of the subtree. So let's look at this example. This is a tree given below, and we can see there are so many subtrees. Basically, each node is a subtree. So the answer will be the node 11 because if you calculate the average of this subtree, you sum the 11, 4, and plus minus 2, and you divide it by 3, and you will calculate out the average of this subtree is 6.5. In the same way, you can calculate this tree, you can calculate this whole tree, and you realize that the subtree 11 is the one who has the largest or maximum average. So this is our problem. How do we do this? Rule number one is that this is the tree or keywords. And the first keyword is this is a tree. So usually for the tree, we know that because this is binary tree, so we know that their structure is always symmetric. So divide, conquer, that's the common techniques we'll be using. And second is that you need to find the maximum average. So basically, we need to calculate each subtree. So we need to traverse the whole tree. So that's the keywords. So basically, in this problem, we'll be using a divide and conquer traverse way to resolve this problem. So let's look at the solution. This is our entrance. Find subtree 2. We're given a tree node. So we need to return the target node. So first, we define the variable. It is called self.target node, self.average, and we just give them an initialize the value, which is the noun, because we haven't started searching this guy, and average is 0. And second, we just call a function that we will be writing later. We call this function helper. The helper actually is gonna do everything and calculate the results. Figure out what is this target node and calculate out the average and assign the values to them. So that's what the helper do. This is our core. So after helper is done, so we're going to just return the answer, which is the self.target node. All right, so let's see what does this helper do. One thing we need to know that in order to resolve this problem, we actually use the divide and conquer. So helper is a divide and conquer method. Helper obviously is a recursive call. And helper is going to return a tuple with two values. One is sum, one is average. So the sum means that the sum of the given tree. The average means the average value of the given tree. So very, obvious. So for helper, because this is the recursive call, so first thing what we have to do is that we need to put the termination condition here so that we can make sure that our recursive call can always exit. If you don't put proper termination condition here, your algorithm may run forever, and in turn you will face that Stack Overflow issue. So we're gonna check the parameter. If the root is noun, then we'll just we don't do any recursive calls, so we just return 0 and 0. That means for this noun subtree, we don't found their sum. We don't calculate their average. We just give 0 and 0. Okay, then next we're gonna just do the divide and conquer thing. The first way, do the divide. In order to calculate the whole trees, the sum and average of this whole tree, we actually just calculate the subtree first. We calculate subtree, sub left tree. We get left sum and left size. and we calculate the sub right tree, we get the right sum and right size. And after this is done, we're gonna do the conquer. We're gonna just use the sub problem answers to calculate our current problem answers. We need to calculate the current sum and average uh, of this current node. So to calculate sum is pretty easy. We just left sum plus right sum plus the current node, which is the root, its value. And the size is also pretty easy. We just left size plus right size plus 1, because the node takes one size. And the average is going to be easy. We just use the sum and divide it by size, because we want the float. So we need to multiply by 1.0. All right. So we calculate the current node sum and average. So we need to do a compare. We need to do a compare with the global variable. And we need to see that if we already found the target node, if we didn't found one, or if current average is greater than the global variable. So if one of these conditions satisfies, we're going to just do a replace. We'll say that the current root is the best target, and the current average is the best answer. So we just update our variable. You can see that this variable is like a global variable, because this variable is out of this recursive call. So you will say once this condition satisfies, we're going to just update our global variable, and after that we just return our answer size, a sum and a size. This is the local answer of this helper. So that's it. That's our whole algorithm. So let's run this. It's great. It's great. It's all passed and accepted. So generally speaking, let me summarize. The first thing is that we look for the keywords. The one keyword is the tree, a binary tree. So we know that they have the semi-tree structure. So we want to use the divide and conquer to divide this big trees problem into a smaller sub-trees problem. In order to calculate the whole answers, we just calculate the smaller problems first. So that's the way how we approach the answer. So just smaller size, smaller the problem size. And number two is that because we want to we use the divide and conquer, so we need to know that usually the divide and conquer strategy it comes with the recursive call. So internally it's a recursive call, so we need to know that every time we need to put the termination condition in the first line, so that we can make sure that we won't be facing any Stack Overflow issue. Because every time when you write that recursive call, Stack Overflow, never ends. This kind of thing really happen frequently. So you need to make sure that it's not going to happen. So the first line is always like this. It's a template. And then you do the divide process and you do the conquer process. Okay, so this is divide and conquer. The second thing is that we need to find a global maximum average. We need to find a global target node. So that's why out of this recursive function, we need to declare a global variable, which is called self.target node, self.average node, so that when we calculate each node in this recursive call, and we're going to just compare it with the global answer. The moment we realize that we found a better answer, we just update our global variable. Okay, so third thing, how do we think of this recursive call? Because when we call this helper function, we actually give the initial node. It is here. So after we call this guy is like because it is the self-calling recursive call. So this guy is like virus just spread over the whole tree. So when we calculate this one, and it's gonna calculate left tree, right tree, and in turn calculate the left and right, and in the end, it's gonna just calculate the whole tree, calculate all of the subtrees. So you can just think this recursive call is like a virus, just spread over the whole tree, and so you won't miss any answers. And also during the process of the calculation, you don't forget to update your global variable to make sure that you found the best answer. Um, this problem is very easy, but if you just look into the details, the steps, the concept, what I mentioned, and also this global variable comparison process, the initializations here, they are all very fundamental. And by understanding this, you can approaching more and more complicated questions. All right, so that's today's algorithm. Thanks. If you like these videos, and please subscribe. And thanks. I see you in next video tutorials. Bye bye.